welcome to my second tutorial video. In this video, I'm going to point out few information that important for energy and conservation of energy. Then we're going to discuss few past year question related to conservation of energy. Okay, so let's discuss or point out important information related to energy. So energy is the ability to do work and it is a scalar quantity. Okay, energy, the unit is joule. Okay, and energy can be divided into two types. The first one is potential energy. Okay, the second one is kinetic energy. Potential energy can be further divided into two. The first one is gravitational potential energy and elastic potential energy. Okay, potential energy is about position, shape, okay, and kinetic energy is about motion of an object. Okay, so the symbol for kinetic energy is K, symbol of gravitational potential energy is big U, and elastic potential energy is US. Okay, so the equation for U is U equal to mgh, and elastic potential energy is US equal to half kx square, and kinetic energy is K equal to half mv square. Okay, next proceed with conservation of energy. So conservation of energy is that initial energy must equal to the final energy. So we have Ui plus Ki equal to U final plus K final. Okay, so conservation of energy. Okay, energy can only be transferred from one type of energy to another type, but cannot be destroyed. Okay, so let's look at the first question, that is UPS 2011-2012, where we have a sphere of mass 4 kg at rest slide along a smooth and curvy surface. So we want to calculate the potential energy and the speed when it reaches a point. Okay, let's solve the first question. Okay, so potential energy, okay, at point A. Okay, so potential energy is U equal to mgh, and our height is 40 meter. So the answer will be 1569.6 joule. And next, for question B, it asks to find the speed as the sphere pass point B. So we need to apply conservation of energy. So E initial equal to E final. Okay, so we have point A and point B. So point A is the initial point and point B is the final point. Okay, so we need to check our potential and kinetic energy at each of the point. Okay, so we have kinetic energy and potential energy at both points. Okay, substitute all the information given and we get the final value for the speed to be 19.81 meter per second. Okay, so next proceed with UPS 2011-2015, where we have a particle moving down a curved track with speed u at a height of 3 meter. Okay, leaving the track, the particle travels straight up and reach a maximum height. Okay, maximum height mean that the velocity equal to 0. Okay, so we want to find the speed u, that is the initial speed. Okay, so list down all the information. We have our initial height 3 meter, final height 4 meter, and we have our final velocity, that is 0 meter per second at the maximum point. Okay, so let's solve the problems by applying principal conservation of energy, where we have E initial equal to E final. Okay, so based on the figure, we can see that initially we have kinetic and gravitational potential energy, but at the final point we only have gravitational potential energy because it reached the maximum height. At maximum height, the velocity is 0. So substitute all the information given. Okay, so we get half u square equal to 9.81. Okay, so u equal to 4.43 meter per second. Okay, so next we proceed with PSPM 2015-2016. Okay, so we have two blocks. One is 2.5 kg and another one have mass 2 kg, and there is a coefficient of kinetic friction 0.1 and 0.18. Okay, and the system is released. So we want to find acceleration, tension, total kinetic energy by using work energy theorem, and the final one is the final velocity of the block. Okay, so first you need to draw the free body diagram because we want to find the acceleration. Okay, so how to draw the free body diagram, it already been shown in the video. Okay, so for the first object we have weight, friction, tension and normal acting on the block, and for the second object we only have weight and tension acting in opposite direction. Okay, so we list down all the forces acting on the block and on the load, okay, in the table of forces. Okay, and we know that the F net at the x component will equal to m1a and y component equal to 0. Okay, so for the second table we only have tension and weight, and for the F net, okay, at the x component it is equal to 0 and the y component negative m2 times a. Okay, so for the block fx equal to m1a. Okay, so we have tension minus with the friction, okay, equal to m1 times a. So we have tension minus 0.1 at normal force equal to 2.5 a, equation 1. And for fy we get the second equation, that is normal force equal to 24.53 Newton. Substitute equation 2 into 1, so we get tension equal to 2.5 A plus 4.41, equation 3. Okay, that is for block, and next we look at the load. Okay, so for load Fy equal to negative m2a. Okay, so T minus m2g equal to negative m2a. So tension equal to 2 times 9.81 minus 2a, and we get the fourth equation. Okay, compare 3 and 4. Okay, so we have 2.5a plus 4.41 equal to 19.62 minus 2a. Okay, so from this comparison we will get the value of a to be 3.38 meter per second square. Okay, substitute this value of a into equation number 3, and we get the value for tension to be 12.86 Newton. And for C, okay, we're going to use work energy theorem to solve the problem, where we have W net equal to delta K, that is change in kinetic energy. So for the block W net, we can express it as the net force times with displacement equal to K final minus K initial. Okay, so initially kinetic energy is 0. Okay, this is because the block is at rest. Okay, so we have K final equal to 2.5, that is the mass, acceleration 3.38, and the displacement 0.6. So the kinetic energy, final kinetic energy is 5.07 joule for block, and for load same method is used. Okay, and we get the final kinetic energy for load to be 4 4.06 joule. Okay, so the total kinetic energy for the system is K block plus K lot. So 5.07 plus 4.06 equal to 9.13 joule. Okay, so for question D, we want to find the final velocity of the block. So we're going to use 5.07 joule. So substitute into the equation, okay, and we get the final velocity for the block to be 2.014 meter per second. Okay, so that's all for this video. Thank you.